This week, my guest is Ian Cinnamon. Ian is the inventor of the world-famous spice that we know and jokes aside, Ian is the co-founder of Apex Space. Ian, along with his other co-founder, Max Benassi, started Apex to build productized satellite buses. In an industry where satellite development often takes years, if not decades, Ian and his team are aiming to create standardized satellite bus platforms that aim to envelope the growing needs of this industry. In this episode, Ian and I talk about the need for standardizing satellite bus platforms, as well as their first successful mission, Aries. We also explore the challenges of scale and the unit economics of satellite production. By the way, Gabe Dominocello, if you're watching, Ian is also a big fan of the word. Apex operates out of a 50,000 square foot facility in Los Angeles, which we got to visit. By the way, this is the first episode that we've shot in person, so big thanks to Ian and his team at Apex for inviting us out there. I hope you enjoy this episode, and as always, if you enjoyed the episode, make sure you like the episode and subscribe so you can follow along. Now, on to the episode with Ian. So
here we are.
Here. Yeah, we made it. Thanks for. This is the first time we're recording live, so you're my first guest. Live.
It's an honor. You know what? This is actually, I believe, my first time doing a live podcast as well. Yeah. So there we go.
I haven't seen it much in the aerospace industry, and I wanted to be able to do this.
I love it, which is ironic because I feel like most aerospace companies are in person.
Yes.
Right? I feel like other industries, everyone's remote, but aerospace, everybody's in person. Yeah. But for some reason, all the podcasts are virtual. But here we are.
There we go.
We're changing the trend.
And we're so close. There's so many companies in LA, and I'm close enough to LA that this is a good opportunity to do it.
Amazing. Well, it's great to have you here. You get to see Factory One and the facility.
This is Factory One. This is the big...
This is where we're going to be able to make well over
100,000 square foot?
No, I wish 50,000 square feet, okay. But we will be able to make over 100 satellites per year out of this facility.
That's the goal. That's the target production rate.
That's exactly right. So we're very, very excited to kind of have this continue to kind of grow and expand here.
That's a good lead into what is the main discussion point of today's podcast is why productize satellites?
Yes.
That to somebody unfamiliar, I have a little familiarity in the industry, being a mechanical engineer in the industry and understanding the value of scale. But for somebody who's unfamiliar with the value of scale, why productize satellites?
It's a great question. So the way that we see the industry is for any system, there's always a bottleneck in the system. And historically in the industry, the bottleneck has really been on the launch side of the equation. So if you want to get an asset, a satellite, a human, whatever it may be, into space, well, you need a rocket to take it from Earth up into space, right? Obviously. However, what we've begun to notice is that used to be the bottleneck, but that is no longer the case. Where it used to be, okay, I have to go wait months, years, even longer than years before I could get a ride to orbit. You used to have to pay hundreds of millions of dollars to get a ride into space. Now, that has fundamentally changed. SpaceX is launching, multiple times a week at this point. We have other amazing companies like Rocket Lab, Firefly just had another successful launch, and more that are coming online. And the result of that is there's an increased cadence in launch and a decrease in the actual price. And what I will say is the price, I think, still has room to come down. If you look at the overall market, frankly, SpaceX is so far ahead of the other launch providers. Until more come online, I imagine prices will stay the same, but eventually when more do, prices will come down. The result of that is if you look at the overall system, right, you can't just have something that launches satellites into space. You need to actually build the satellites. You need the ground infrastructure. You need everything else. So when we see it, okay, launch was previously the bottleneck in the system. That is no longer the bottleneck. What is the next bottleneck in the system? And based on all of the work that I did before I started Apex, both on the investment side, also when I was working at Palantir, leading a lot of our satellite efforts, what my co-founder did at SpaceX and Astra as well, we noticed that the biggest bottleneck now was actually mostly on the side of how do I get my payload, the sensor, whatever it may be, up into orbit? That was the core question. And what the result of that was the satellite bus, the core set of components on any satellite, seemed to be the slowest and most expensive part of the puzzle. You could get a ride to orbit more quickly, you could build your payload more quickly, but getting the satellite bus built was something that was, frankly, the long pole in the tent.
How did that previous experience shape you? You mentioned you touched on Palantir, and before that you were in computer vision systems and AI. Right?
Yes.
So
not your traditional aerospace background.
Well, I would argue closer to a traditional. Isn't it the billionaire aerospace trajectory where you start a software company and then you start an aerospace company?
That's exactly right. If I were a billionaire, the problem is I am many, 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 many orders of magnitude away from that. I would say I am far closer to zero than I am to a billion. Anyway, yes.
How did that prepare you? How did that prepare you to start Apex? So paint me a picture of what younger Ian was, and were you always interested in space before you tried these different career trajectories before you landed on Apex?
So I would like to say that I went back and forth. So I started out loving the space industry. But when I say started out, I mean a little kid, right? So I grew up here in Los Angeles. Some of my favorite memories growing up were my dad would take me out to the middle of the desert in the Mojave Desert. And we would go get these like SD rocket engines. We'd stop at a gun store on the way there and buy black powder. We would try to make my own rocket engines, etc. I didn't know what I was doing, but I loved it. I love the idea of like you build something with your hands and it can leave the ground.
The Friends of Amateur Rocketry site.
Exactly. That's exactly right. Many times out there. I started like the rocketry club in my in school and did all of that. But what was interesting is I went to MIT for my undergrad. And when I got there, I said, okay, look, I know I like kind of the world of rocketry. I like robotics. I like programming. I like all of these very cool technical things. What do I go do? And I explored by taking classes in a variety of different industries. And what I realized was, while aerospace to me was a passion and fascinating, it felt like the iteration speed in the industry was just slower. And you pair that with seeing something like software, where frankly on software, like you can go and, release a new software product multiple times a day. Whereas in aerospace, like you have design reviews, you have to go test it. It's months or years before you could release.
What is the average, before you started Apex, what was the average cycle time for getting a spacecraft with a customer saying, yes, we'll buy your product, go design it, to launch day?
So what
or delivery?
I don't know the exact numbers, but what I would tell you is what it is today. So I can only imagine back before I started Apex, it was worse, but I could tell you today. So if you look at the industry today and you go to a traditional satellite bus supplier, of which, by the way, these satellite bus suppliers have been phenomenal for the industry, right? They're the ones who allowed the industry to exist. So I don't mean any negative towards them, because they still have an important piece of the puzzle, but they will go build something custom and bespoke. And that can easily take, on the short end, 2 years. But honestly, this in aerospace, how often are timelines accurate? Not very often, right? So it's usually 3, 4, 5 years.
Forget about interplanetary missions, especially if you're going to Mars.
Exactly. Yeah, exactly. It's going to take a while. Yeah. It's going to take a long time. So that was really the pain point that we saw. And I noticed in, my background, my education, that waiting years before you could launch a product just felt painful, right? How do you speed that up? How do you make it go faster? So I started my career on the software side because of that faster iteration speed. Moved out to San Francisco, had an amazing experience, kind of learning from a amazing entrepreneur by the name of Mark Pincus, who he had taken a couple of companies public, really kind of mentored me, guided me in what it was to be a founder, be a CEO. And most importantly, if you're going to go start a company, go big, right? If you go start a company, you're not going to go say, oh, I'll go dabble in this. You're going to give it your all, right? You created this thing. You want to bring it to life. You want to make it exist. You're going to put in 200% of your energy. If you put 200% of your energy into something that's small, why not do it into something that's big, right? It's the same amount of energy. So why not go for something much bigger? So that was an important lesson for me. I ended up moving over on the software world to doing computer vision, which is closer to what I studied when I was at MIT, and started a company around that. And we were applying computer vision to downstream satellite data. And that is how I got back into the industry.
Like satellite imagery?
Exactly. So mostly commercial satellite imagery. And what we were trying to understand was what was the art of the possible if you were to apply AI to what is just commercially available. So not government data sets, but if, for example, the government wanted to take advantage of Planet Labs or Capella or these amazing other kind of sensing companies, what could they do with AI that they previously could not do before? That was really what we were focused on.
Wonderful. Yeah, that's that's been a big boon for the industry. Commercially available open data, and one of the companies that really talk about commercially available open data, I think we talked about this before, is Umbra.
Yes.
Out in Santa Barbara.
Huge fan of Santa Barbara and of Umbra.
Umbra is great because they have been the first company who's been very vocal about providing open data sets for people to explore and do things with. But something else Umbra has been very passionate about is the unit economics of satellite, of satellite imagery, which I see you've talked about unit economics of satellites themselves.
Yes.
What is the driving factor that's at this time in the industry that's reducing or increasing the cost of unit economics and setting the industry back a little bit?
Yeah, so I go back to kind of the system overview I described before, right? So you can't look at anything in this industry by just saying, well, how much does a satellite image cost? Or how much does a satellite bus cost? Or how much does a rocket launch cost? You have to look at it all together. And what I mean by that is it's a pretty simple equation, right? For a given satellite, right? A given satellite needs to get into orbit. So there's some costs to actually get into orbit. The satellite itself and the payload cost some amount of money. So you incorporate that as well. And then you have to communicate with the satellite. So your ground costs, downlinking the imagery. So those are pretty much at a high level, all of your costs, right? There's a whole lot more like mission ops and all of that, but high level.
That's the end-to-end cradle-to-grave cost of a satellite.
For a single system. Then you have your revenue driver, right? So that's how much can you actually sell images for, which then you look at, well, how many images can you actually generate? What's the revisit rate? What's the value of the images, et cetera? Now, that's on the commercial side. Government side, I would argue there's a similar equation, but it's not revenue driving. It's more, maybe if you were to figure out a metric to put a price on that intelligence that you're gathering, right? There's some other metric you could put there, right? And look at the cost versus kind of how valuable of an asset is that in orbit.
We can call it timeline to action.
Exactly. I love that. Timeline to action. So whether you're commercial or government, there's some positive outcome, right? It's revenue, timeline to action. And then you have to look at the full costs. So what I would say is on the unit economics overall, what we've seen is the cost of launch come way down. It's been steady for a couple of years now because there's no reason for SpaceX to lower their prices because their competition is much higher than them anyway. So why would they lose money? You have the satellite bus side of the equation, which I would argue has been historically fairly expensive for buying them. I would also argue that the timeline to receive them has to be incorporated into the equation because you can't just look at it as this all happened at one moment in time. You have to look at the time value of money, right? So if you go say, I launched my rocket and the satellite deployed and I make money, that's great. But when did you start spending that money? If the satellite bus took 4 years to build, you've been spending that money for 4 years before you start to recoup it. So the IRR on your investment is probably much lower. So you really have to think about all of that. So if you ask me, like, what's the single biggest thing I think holding back the industry in terms of better unit economics, I would argue it's actually the timeline and being able to get more assets up more quickly. Of course, reducing their costs, but I would say like launch has already come way down and there are ways to get the satellite bus price down, like working with a company like Apex.
Yeah. So those are you've highlighted the two biggest constraints that we as integrators of satellites or customers of satellites see is like, can I get this fast? Can I get this cheap at a markup that's not super high? So what's been the target focus of that $95 million Series B funding round? Like, what are you taking that capital now, and what is the first challenge you're trying to go tackle?
So before we raised that $95 million, we had been laser focused on our Aries product line. So that's our ESPA class vehicle. It's already in orbit. It works great. We have customers for many, many more of them. They're being built right now in our clean room. That's moving along quite nicely. But what we noticed was as we grow as a company, it's important to not just win customers that want to focus on, hey, I want to get one demonstration satellite to orbit or maybe 2 or 3, but how do we focus on the customers who really want to get a constellation and operational capability in orbit? And what that requires is usually a larger satellite bus platform that has a little bit more redundancy, is really built for operational measures as opposed to just a quick demonstration. So the $95 million Series B really enables us to put the foot on the gas with Nova, which think of that as our Espa Grande platform. And keep in mind, Espa Grande, yes, there's formal definitions. I use them very loosely because the way that you could think about it is instead of a 100-kilogram bus, now we're talking about a 300-kilogram bus. So we're just getting bigger on the bus size.
I think of a Starbucks cup when you say grande.
Exactly. I feel like that's a better way of saying it. It's okay. We have our tall, we have our grande, and then we'll have our venti one day. Yeah. Exactly. So we go in that direction. Maybe a Trenta. Who knows? Yeah. But the grande latte that we have, which is Nova, that's really the bulk of our resources and where we're going right now, which I think is such an important piece of the puzzle for those real constellation customers. So that has been a big use of funds, just getting that, not just the engineering wise, we've been working on it for a while, but getting production ramped up on it, very important. The other thing as well is moving into new orbits. So Aries and Nova from the beginning were always initially designed as vehicles that will go into low Earth orbit, but we've always had strong customer interest to move beyond just low Earth orbit and move into places like GEO or MEO or deep space and beyond. So because of that, we have parallel development efforts that we now can do because of that Series B to create what we call the GEO version of Aries. That will be able to take that Aries vehicle, but use rad-hardened components, use more redundancy. You obviously need different ADCS and radio systems, so it'll actually work in a geostationary environment. So we'll more on that soon, but we're excited for both those efforts.
Yeah, just for folks who don't know, since I'm in engineering, and I love to nerd out about this. The low Earth orbit is proton-dominated radiation, and GEO is electron-dominated radiation. Isn't that distinction alone sort of start getting into the territory of like, I need to start customizing my components, I need to customize my satellites? So how are you tackling that from a scale perspective?
It's a really good question. What I will say is, what you're kind of alluding to is on those on LEO components, right, where you have a less intense radiation environment, there's a lot of off-the-shelf components you could use, right? Frankly, you could use a lot of terrestrial components, and you can either just put the right shielding in place or test them or, upscreen them, but there's ways to do that.
Kapton for ATOX.
Exactly, right? And like we've done that extensively on Aries, proven it works, that's great. GEO's a whole different ballgame. And in order to do that, it's a combination of, you could still do some upscreening of parts, you could still do some kind of shielding to make it work, but what it really comes down to is our customers need the bus to work, right? The bus has to deliver for them. So really what we do is, it means we work with our supply chain to who've already created these rad-hardened components that will work. And we, instead of us saying, let's go build our own, what we do is we try to enable our supply chain. So whether that's helping them understand how to scale production, which is one thing that we are very, very good at. So taking some of our engineers, going on site there, showing them how they could speed up processes, or things like, does it make sense to potentially invest in some of our suppliers and, really help them kind of ramp up. So we've been looking at it from both of those perspectives. I will say supply chain on GEO, much longer lead time than on LEO. I'm sure you're well aware.
Supply chain is always
brutal.
I think
brutal.
There are different parts of our industry that are looking to tackle supply chain, like First Resonance and a couple of other folks. I think you hit on an interesting point. It sounds like Apex is trying to thread the line between being enough vertically integrated, but keeping the flexibility of horizontal integration.
Yes. So we have a very transparent and simple philosophy on supply chain, vertical integration, et cetera. So I'll tell it to you and you tell me what you think of it. But effectively, our preference is always to use a supplier, right? To purchase parts. But if we purchase parts, we have very important requirements, which is the supplier must meet our reliability criteria. So we have to know it works as a TRL9, but TRL9, that doesn't mean, oh, it's flown. It's like, how many have flown? What's the failure rate? Where has it gone wrong? Things like that, really digging into them. We need to know how quickly can you get us the parts? What is the lead time? Now, on the lead time, that's where we'll maybe help those suppliers get better. We maybe can help invest or share some resources, et cetera. And then finally, it's do you hit our cost targets? And if we find one supplier for a given component who meets all three of those criteria, we then say, great, let's find a second supplier that meets that criteria. So we will always dual source, right? We're never going to rely on just a single supplier because we have to be in that position where we can actually dual source that. Yeah. So if we cannot find a supplier that meets all of that criteria, then what we have to do is we have to vertically integrate. But that's not our preference, right? Our preference is to always be able to dual source and work with suppliers if possible.
So reliability,
lead time and cost. Exactly. Okay. That's exactly right. Our customers, like, we're in a situation where, let's say you have an amazing payload you want to fly, right? You go spend all this money, this time. Let's say you have your own company. You're going to generate revenue from this payload. If the bus does not work, that's a non-starter for you. Similar to like on the launch site, how would you feel if you booked a flight on a rocket and it did not make it to orbit? And your satellite, your payload was working, your satellite is working. Like, how devastating is that? So you have to have trust in us that it'll work. So reliability, number one, most important. And look, we're not building Class A systems, but we're building systems where there's heritage, there's a track record, and we're happy to go into all that engineering detail with our customers.
Yeah. So you hit on a very interesting point, which is a lot of the new space satellite startups that I've come across have had their first launch fail on orbit because of a unreliable component. SATA failures. I think there was another company that had tumbling in orbit because of attitude control issues. Which brings me to the counterpoint that Aries holds a world record unofficially, that it is the first production run of a satellite that has made it to space in working condition in the fastest time.
I hope that's right. So what I will say is, somebody the other day said, Ian, you keep describing this as you set to the best of your knowledge a world record. And they said, why do you say that? And I said, well, I don't know. Like, maybe there's something I don't know. So my thought here is, we should call up the Guinness Book of World Records, who is the official record holder for these types of things, and see if we could get a Guinness Book of World Record. That's what I think we got to do.
I feel like there aren't enough space records represented, so I'm thinking of starting just a website to put up records of new space companies.
I love it. Who needs the Guinness Book of World Records? I want that website. That's all we need. I will say, though, having it work is important, right? I would say it's bad for the industry when there's any failure. So I hate seeing failure on orbit. And there's been, look, it's not just new space, right? Space is hard. Look at Starliner, who's currently docked on the ISS and is having issues. Like, that's not something to celebrate, right? That is terrible, because having to say, okay, the Starliner no longer works, and now we're solely dependent on Dragon, which, by the way, Dragon, SpaceX, incredible company, amazing. But just as a citizen of the planet and wanting more and more access to space, I want to see more vehicles flying and more success. So, I think the two most recent issues that we've seen, and I say this because they were on the ride to orbit that we were Transporter 10 or the one before Transporter 9, like seeing what True Anomaly went through, losing their two spacecraft. I mean, I feel terrible for them, and we tried our best to kind of help them on orbit as best we could, but like, it is a really tough situation. I'm so happy that they continue pushing forward. Or even Impulse, right? Impulse is an amazing company, but hearing the news, I think it was last Friday or maybe the Friday before, they announced that they had lost contact with their satellite, right? After, less than a year on orbit. And like, that is so tough, right? And they're an amazing company. They build amazing systems, but to have a communications failure in less than a year in is just, it's really tough, and it's not good for anybody. Like, I want to go be a customer of Impulse and use their OTVs. Like, that is tough. Yeah. I'm like very excited for all of that. So it's really tough. That being said, we've only been on orbit since March. Everything is working really well. We have multiple customers on there. They've all used it. Their payloads all work. We have our cool selfie camera. I think we've shown off some images, and it's working really well. But look, things go wrong all the time. So we don't think of our first mission as complete. We think of it as it'll continue to be in progress. For us, it's an in-orbit testbed that we want to go use for many years. So,
and it's TRL-9.
It's TRL-9, but it's not something that we're like, oh, it's in orbit, it's done. It's something we continue to stress test every day because we want to prove to our customers that we have that high reliability.
Space industry we're in right now has a lot of energy. I do worry sometimes if it's a bubble. There's a lot of folks who think the launch industry is a bubble, that there's a lot of launch companies.
I would say the launch industry was a bubble because I think most of those companies have now died and the bubble has been popped. But okay. I agree.
Okay. That leads into my question. We know that spacecraft manufacturing is hard. It is understated the importance of that manufacturing has to take place in this industry. Are we approaching this bubble where people don't really underestimate how hard it is to make a lot of spacecraft at scale?
I think of it in two ways. So I think, is there a bubble in terms of the market, right? Like, are we in a situation where, there's like too many companies out there that raise money in a zero interest rate phenomenon environment and are going crazy? And then I also think of it as, do people just underestimate the production and how hard this is to do? So I'll start with the first one, which is the industry as a whole. Look, I describe ourselves as a new space company. You describe us that way as well. It's fair. I like to think of us, though, not as a new space company, but just as a reputable satellite bus supplier. Because I think the problem is there's a lot of new space companies out there. A lot of them, frankly, are science projects that don't really have positive unit economics and a real commercial interest. Mm-hmm. And I think those are actually more a detriment to the industry than they are helpful. Because I think the more people that start businesses with real unit economics, where it's a real business and it's supplying a need, it's going to push the industry forward. Mm-hmm. So that's the first thing that I'll say. So I think there's definitely going to be a little bit of a reckoning as, the companies who raise money in zero interest rate times find it hard to raise money now. And again, look, I wish the money was just flowing, but we as entrepreneurs have to be realistic about the economy and where things are, and you have to build a real business. In terms of production, what I would say is we build our satellite bus platforms as a true product, but we don't do that for fun. We do that because of the pain points I mentioned earlier, which are cost and lead time and reliability. And my co-founder, Max, incredible engineer, incredible production, spent his career at SpaceX. We came together and we said, we need to figure out how to build satellite buses for a lower cost, for a much faster timeline, and have them be very reliable. And what we realized was if we redesign it every time and we go through new non-recurring engineering, it's impossible, right? Because you change something, the reliability might go down. You change something, you're spending a lot of time on engineering to go do that. You don't know what the cost will be. So the only way, in our opinion, to solve that problem is to truly build a productized satellite bus, where we talk to customers, we define what the specs are, and then we go build them at scale. That's how we think about it.
Yeah, and then I'm sure enveloping, sort of like, you don't want your customers to go necessarily change things for you. So enveloping that whole requirement set with three different categories: Aries, Nova and Comet.
Yep.
So we've talked about Aries and Nova. What's the one sentence elevator pitch for Comet?
So think of Comet. You probably saw it on your way in when you walked in here. That's that large. The camera can't see it, but behind the camera, there's a very large satellite bus over there. Still a small sat. So Comet is, think of it as, it's not designed for a one-off, right? It's really designed to maximize how many can fit in a single Falcon 9 fairing, and it has a massive aperture. So what that means is if you're a commercial customer looking to do a direct-to-device constellation, IoT, you need a huge antenna, Comet is absolutely perfect. If you're a government customer looking for some, intelligence gathering missions where you need kind of a large antenna size, Comet is perfect. But it's not intended to be a system where you just go buy one of them. It's intended to be a system where it's flown as a full fairings worth of comets for those true constellation customers.
That is interesting because the DoD just put out a statement saying they're looking to move away from large geobirds for comms resiliency.
Exactly.
And that seems to fit perfectly
That's
in
right.
that
And
market too.
what I find so funny is in my mind, because we start with something like Aries, which is 100 kilograms, Nova 300 kilograms, and you have Comet, which is like 500 kilograms and just like physically massive. I'm like, that's such a big satellite bus, but it still is a small sat compared to these big geobirds that are like absolutely enormous. That would fill up most of this building.
And yeah, filling up an entire payload fairing worth of Falcon 9 is a lot.
Yes.
But I'm curious how Apex is thinking about the Starship era and the Starship inflection point.
Yes. So very excited for Starship. What I will say though about Starship that we are looking at very carefully is two things. So one is, when will it be available for customers to use? And what is the price to launch on it? So here's the things that we know about Starship for sure, right? Incredible mass to orbit, right? In terms of just what it can get up there. Incredible ability to fly at a fairly low cost. Now, I think the thing that a lot of people mistake is cost versus price. So even though SpaceX might be able to, fuel up a Starship, refurbish it, and get it to launch for, I don't know what the dollar amount is, but some lower dollar amount, such that the dollar per kilogram to orbit is maybe, instead of, a couple $1,000s per kilogram, maybe it's $100 per kilogram.
That's the target.
That's the target. If you're SpaceX, you're not going to go charge a customer $100 per kilogram. You're going to say, well, what am I going to charge a customer? I could charge them what I've been charging them, which is $4,500, $5,000, whatever the number is, dollars per kilogram, and I will enjoy that margin for me. So I think something that we tend to be very focused on is like, well, what will the actual price be to fly on Starship? Not necessarily what is the internal cost to SpaceX. And that's, I think, a very important distinction that a lot of journalists and entrepreneurs sometimes forget to think about.
So you're saying that you're not optimizing to be first to market for a new product on Starship. How important is being first to market?
So what I would say is, the next question that we have is like, when will first to market on Starship actually be? So we know from what we've read online, and so maybe you know more than I do, that Starship's initial primary purpose will be to get more and more Starlinks into orbit. And then we know that there's the HLS contract for Starship as well. So that is probably going to occupy a lot of time. The next question will be, okay, great. Once that's going, then will SpaceX open it up to commercial companies to buy a full Starship, or maybe they'll open it up to do a rideshare mission? I don't know. But I still think that we are far enough out that it is impossible to optimize to be that first customer. The other thing that I'll say is, we just build the buses. We have a very simple business. Our customers of the buses are usually in charge of procuring launch. So it's very important to us to be compatible with every launch vehicle, and of course, including Starship. But it's usually our customers who are figuring out, okay, I'm going to go book Starship, or I'm going to book Falcon 9 or PSLV or whatever it may be. That's how we think about it.
Okay, that's fair enough. Another cool thing that I saw on your website is that you famously have the e-commerce workflow platform. I first learned that on the Payload podcast, and then I went and looked at it, and it's really cool.
But I haven't seen you buy a satellite bus on it yet. It's only a few $1 million. Don't you want your own personal satellite?
I would love that when the cost drops to like a few thousand. So the unit economics, when they come down.
We'll put you in the pipeline for like 2050. Don't worry, we're on it. We'll check back in a couple decades.
I think that's the we joke about it, but I think in all seriousness, that's where the industry could be heading in the next 50 years.
That's our dream. I would love that. I want it to be like buying a car, right? Everyone has a satellite. Everyone has this. Oh, you need that. It's not something where you're like, oh my God, I have to go plan years in advance.
Yeah, I go back to my last two episodes with Umbra and then CEO of Skyfi, Luke Fisher.
Yes, Luke is amazing.
Who
you have some great guests on your podcast. What are you doing with me?
You're a great guest. That's why you're on the podcast. But Luke famously talked about, hey, if I can get an Uber, I should be able to order a satellite image on the phone.
Yes.
And that's the future we're approaching. I'm glad that Apex is already doing that, although you still need a couple $1 million to buy a satellite. But why has it taken the industry so long to adopt the model of e-commerce?
Yeah, it's a good question. I think it comes back to the productization. So historically in this industry, like we were talking about, 2, 4, 5, 6 years to get a satellite bus built. That's because it's custom made and custom designed. You have brilliant engineers who clear off this table and put a blank sheet of paper and say, let's start from scratch. Let's build you a new satellite. And if you have that, how do you put that on an e-commerce website? Like, satellite design services, like X dollars an hour? Like, how do you even bill for that? But because you have a productized satellite where we say, here are the specs, here's the spec sheet, here are the 3 different solar panel options. Do you want SATAs or no SATAs? Like, you pick. We have a limited number of SKUs or product offerings, meaning we know the price of all of those, meaning we can put them on the website.
Scan a barcode.
That's exactly right. I would love to have shelves of satellites in this facility where you could come by and you'll be like, I'm going to take that one.
Sure.
But that's really the idea. You have to have a true productization to have it on the website. And I will say we've had customers buy full satellite buses now on the website, which is really cool. Like, they put in their credit card, they put down the deposit, we send them the full contract.
And what is the turnaround time to something like that?
Well, so the way that we think about your turnaround time in terms of how soon can they get their bus? Yeah. So the way that we think about satellite buses is not what is the lead time to get you a bus. Mm-hmm. Instead, we think of it much more like an automotive manufacturing company, like a Toyota or a Ford. And if you're a Toyota, and let's say we both drive Toyota Corollas, right? Mm-hmm. You go to the Toyota dealership and you're like, well, I want this. Let's say they don't have it on the lot. You're like, I want this Toyota. They're not going to go call up the Toyota factory and say, all right, go make this one. The Toyota factory is going to say, okay, we're making, I don't know, some number of cars this year. And of the cars that we're making this year, this car right here on the production line will either match the specs that you wanted, or we haven't decided the specs yet. So it could be the specs you want. Therefore, the production line will have your car ready by, I don't know, it's August today, October, making updates. We think of it the same way. We have an active production line. And if you come to buy a bus, depending on your configuration package, it might be one that's literally sitting on the shelf, like on the lot of a dealership, and we could say, all right, bring the forklift, it's yours. Mm-hmm. Or we say, okay, great, our next production line where we're popping out one with SATAs and 3 panels will be in November. Does November work? Yeah. So it really depends. Yeah. For the one that the customer bought when they bought it online, which was they bought it a few months ago, we had sold out a lot of the production slots, but they got one that will be delivered at the end of this year. Yeah. So just a few months.
Cool. In the final few minutes we have left, again, I'm very appreciative of your time.
Of course.
I have 2 questions for you.
I'm ready.
Well, 3, but we'll try to get to all 3. I see that people in this industry companies in this industry that really win are folks who place contrarian bets and are correct about the contrarian bet. Yeah. An example is Elon placing a contrarian bet that, hey, why are we throwing away rockets? That doesn't make sense. We need to reuse them. You won't throw away an airline. You need to be able to reuse rockets, bring the cost down. People laughed at it. Now we know the story and we're in present day. Apex is taking a contrarian bet, and for all of us in the industry, I hope all of those contrarian bets in the new space industry pays off. But besides that one, besides what you're working on, what is another contrarian bet in the industry that you think will materialize in the next 15, 20 years?
All right. So I have one that's way out there, and it's way out there. It's funny. This is somebody who they actually looked at buying a bus from us. And one of the things I'm very proud of is if a customer is not a fit for us, we will tell the customer. Like, if a customer says, I want your bus, but go make these modifications, we'll politely be like, sorry, go work with a different bus company. So this was somebody that came to us, but it's asteroid mining. So asteroid mining sounds like science fiction. And it's something that's like way far out there. But I really believe in the next 2 decades, we're going to be returning like rare earth metals, like platinum from asteroids. And somebody is going to create $1 trillion company doing that.
Astroforge and
I love that. I'm a big fan of Astroforge. Yeah. So they're great.
Yeah. I had the chance to meet Matt.
Matt's incredible. Yes. He's been a huge supporter of Apex from the very beginning. And I was one of the first investors in Astroforge, so it goes in both directions. Yeah,
Transporter 11, they might be flying on that soon, or
yes,
or the next one.
I think so.
Yeah.
I think so.
So very excited for them, and very excited to see. And I hope to have Matt on the show.
Absolutely. I'll bug him right after this.
Perfect. For future founders in this, there are going to be so many. I draw the analogy of the space industry to how the World Wide Web developed.
Yes.
Web 1, Web 2, Web 3, where there are a lot of founders that suddenly popped up because of all of these infrastructure and services that people enabled for us.
Yeah.
What's your advice to future founders in the new space industry? Should they be building hardware, software?
Software is great, hardware is great, everything in between is great. Most important thing by far, build a real business that makes money. Don't go doing a science project. Go build something that has revenue that comes in. Your revenue is higher than your costs. Like it's a real business. It doesn't take you a decade. It doesn't take you $1 billion to get there. I would say the sooner you can control your own destiny by being cash flow positive or profitable with the minimum amount of money that you need from external people, the more in control you can be and the more you can scale.
Being from the software industry, do you see if is there a space SaaS product that's ripe for disruption? Just from your...
So what I will say is 100% yes. I'm a huge fan of companies like Epsilon 3, First Resonance, et cetera, like amazing companies. I love them. They're tackling something though, if you look at both of those companies, that's not just space, right? They do great work in space, but they do more than just space. I think a SaaS company that is solely focused on space can absolutely be a great company. Do I think it can be a 10 or $100 billion company in today's market? Maybe not, just because I think the market size is not quite there. But if there are companies like Epsilon 3, for example, that expands beyond just space, which they've done a phenomenal job of, then I think there's room to be a huge software-only company.
I think it's volumes, right? Like there
Exactly.
aren't as much volumes. And I think you said that before, like our industry is not 1 to 10. It's not a million plus. It's somewhere in between.
That's precisely right. Exactly.
Yeah. Okay, my final question. I think it's the hardest one.
Uh-oh.
So you said that you tried to get people to rename their dog Comet.
Yes.
But what about cats?
Okay. It's a really good question. I will say we have some amazing cat lovers in this company, and we have officially updated our satellite naming policy, which is it does not need to be a dog with a space theme name. It just needs to be a pet with a space theme name. So we are equal between cats, dogs. We have amazing employees with goldfish. We've had people talk about getting turtles, lemurs. I don't know. Everything is on the table. I feel like one day there will be a zoo. We actually let people bring their pets into work, which is very exciting. So far, we've only had cats in the office, dogs in the office, no cats yet. But I'm hoping that we get more space-themed pet in the office. That would be wonderful.
So if I get a cat and name and comment, I'm going to get to the front of the line.
You will be number one in line. I promise you that. Amazing.
Amazing. Thank you so much, Ian.
Thanks for taking the time. Really appreciate you coming out here.
Yeah. Thanks so much for listening to that episode. And because you stuck around, here's a little post-credit scene.
So I think
it's all good.
Of course. Do you want to do just in the same position?
Oh,
I think what you can because we lost a little recording time because this thing overheated, so it's just really.
Oh, interesting.
You guys are like,
Yeah. Look at the camera.
Please. And then maybe one where you guys look at each other. You guys are talking. Wonderful.
Cool.
Thank you so much.
This is awesome. Thank you guys.
This was fun.